All right, today we are doing section 5.6, day 2. We only have one more section of new notes after today for the semester. For today, our objective is to identify complex numbers and to perform operations with them. Remember last week we talked about imaginary numbers. They're also referred to as complex numbers. We'll talk more about what that means specifically today. Any imaginary number can be written as a complex number. That's why sometimes they're referred to as the same kind of thing. All right, our notes state imaginary numbers and real numbers make up the set of complex numbers. A complex number is of the form a plus bi. Now, just for fun, who remembers what I stands for? Or what I equals? Charles?
-1.
Close, not just -1. Jacob? The square root of -1. That's what we talked about on Friday. A is the real part. B is the imaginary part. So on Friday, I introduced you to the term complex at the very beginning. So that's partially because if A is 0, 0 is a real number, 0 plus bi is still considered a complex number, even though we don't usually write the 0. But it's just a matter of formalities, really. All right, so let's write these ones where A is not 0. Write them in a plus bi form. So on both of these, which number do you think needs to come first to represent the A?
6.
The 6 on number 1. The 6 needs to come first. And what about on number 2?
7.
The 7 would have to come first. So that's important. The real number part comes first. So that we know already that this has to be rewritten as 6 plus. Then we deal with the square root of -9. Who remembers how that will simplify from Friday? Charles? 3i, good. Remember we talked about splitting the square root up to -1. The square root of -1 times the square root of 9, where the square root of -1 is I, the square root of 9 is 3. So we would have 6 plus 3i. That is a plus bi form. Number 2, we already talked about the fact that the 7 needs to be in the front. That's the real part. And then for the imaginary part, we're taking the square root of -18. Is -18 a perfect square number?
No.
No. So what do we do to simplify it? A factor tree. So 18 factors into what? 2 and 9. 9 factors into 3 and 3. So what do we have a pair of? 3's, and what's alone? The 2. So remember, we still also have to factor in that negative part. So how would I rewrite the square root of -18? Very good. 3 square root 2i. If you were to put your I in between the 3 and the radical sign, that's okay. Either one works for me. We would prefer the I at the very end, but we don't want to make it look like the I is underneath the radical. The absolute value of a complex number. To find the absolute value of a complex number, you must use the formula. The absolute value of a plus bi is equal to the square root of a squared plus b squared. Notice that the I is not involved underneath the radical of that formula. All right, find the absolute value of 5i. In order to do these, we have to be able to identify the a and the b from these. On number 3, what do you think a equals? 0. There's nothing there. A equals 0. What does b equal?
5.
5. Remember, the I is not included. So we are using this formula, square root of a squared plus b squared, to find the value of it. So on example 3, here's my work. The square root of 0 squared plus 5 squared. What is 0 squared?
0.
What is 5 squared? So we have 0 plus 25, which equals 25. And then we take the square root of 25, we get 5. And that is our answer. So the absolute value of 5i is equal to 5. Remember when we were talking about just real numbers, absolute value was the distance to 0 on a number line. When we're dealing with imaginary or complex numbers, we're dealing with a coordinate plane more so. So it's more complicated than just a straight line distance on a number line. All right, on example 4, let's first identify our a and our b. Anybody tell me what a equals? Sadia? 3. And what about b?
4.
Good, -4. Now technically, since we end up squaring b, if you were to use a +4, it would come out the same, but we should be precise in our work. So we plug those in, a and b, into our formula. The square root of 3 squared plus -4 squared. What is 3 squared? 9. What is -4 squared? 16. When I add those together, I get 25. And the square root of 25 is still 5. So these have the same absolute value, even though they are very different complex numbers. Questions about number 4?
No.
All right, somebody I have not heard from yet today, help me out with a and b on number 5.
You said A and B?
Yep.
Oh. A is -2
Okay.
and B is 5.
Wonderful. A is -2 and b is 5. We're going to use those in our same formula. The square root of -2 squared plus 5 squared. What is -2 squared? 4. And 5 squared. And if we add those together, will the square root of 29 simplify? No, it doesn't even break down with a factor tree because 29 is not just odd, but is prime. So we would say that this one is equal to the square root of 29.
Does it have to be the square root?
Yes, if we leave off the square root symbol, it is not correct. To add or subtract complex numbers, combine the real parts and the imaginary parts separately. This is just like if you were to do this with variables. So if instead of having i's, we had x's, same idea. Okay, you have to only combine like terms or like parts. All right, on number 8, we go through and we add or subtract the real parts, and then we add or subtract the imaginary parts. So for the real parts on number 8, I'm adding 5 plus what? 5 plus -2. What does that give me? 3. And then I've got 7i plus 6i. What does that give me?
13.
Not just 13, but
I.
13i.
13I.
There we go. That's it. That's all we got to do.
Okay.
Number 9 is a little bit trickier because we have to remember that we are subtracting. So I have 8 minus 2, which is 6. And we have 3i minus 4i, which is negative 1i. So if you want to put the 1, you can, or you could just put minus I. Either way works for me. Additive inverses of a complex number. So to have an additive inverse, it means that you would add it to your original number to get 0. Okay, so when we talk about additive inverses in the real number world, we're talking about opposites. 2 plus negative 2, those are additive inverses because they add up to 0. So, in that line that you've got there, we're supposed to put the general form of the additive inverse for a complex number. So normally a complex number is written as a plus bi. What do you think we would have to add to a to cancel it out? Negative a, the opposite of a. So negative a, what do you think we'd have to add to bi to cancel it out? Negative bi. So the additive inverse, that's what goes on that line here, is negative a minus bi. That's the additive inverse for any complex number written as a plus bi. So with that in mind, can anybody tell me what they think the additive inverse for negative 6i is? Jacob? Positive 6i. Very good. And what about 4 minus 3i? Charles?
Negative 4 plus 3I.
Good. Negative 4 plus 3i. For additive inverses, you're trying to come up with the term that will make your original problem go to 0 completely. So we switch both of those signs. Multiplying complex numbers is probably the most applicable thing that we will talk about complex numbers for in the future. Used the most. We'll use it the most out of all these topics we've talked about today. You can multiply 2 complex numbers by using the procedure for multiplying 2 binomials. So that might mean that you're using FOIL in your notes instead of FOIL. It says double distribute because that's what we like to use more. Double distribute. If you learned FOIL and you like it and you want to use it, that's fine. It's the same idea. We just prefer to call it double distributing these days. On 10 and 11, there is not any double distributing to be done. We're just going to multiply them together. So kind of like we do when we've got variables, that's kind of how we're going to treat these i's. So 5i times 4i, we're going to multiply the 5 and the 4 together. What do we get? 20. And I times I is I squared. Good. So normally when we're dealing with variables, we would stop there. However, I is not just any old variable. I represents the square root of negative 1. So remember in your notes last week, we had that I was equal to the square root of negative 1. Does anyone remember or want to flip back and see what I squared equals? India? Negative 1 without the square root sign. I squared on its own just equals negative 1. So that means that we are taking 20 times negative 1. So it's negative 20. Very good. So the answer on this one is actually negative 20.
No, we don't put I.
Nope, because instead of having I squared, we replaced it with what I squared equals, which is negative 1. 11 is similar to number 10. We're going to multiply 12 and 7. We get 84. We multiply I times I. We get I squared. But we remember that I squared really equals -1. So we have 84 times -1, which gives us -84. Okay, so the hint or idea at the end of those notes up there is that if we're multiplying two complex numbers together, we would double distribute. So let's rewrite number 12 so I can show that work. 6 minus 5i times 4 minus 3i. We're double distributing, so that means we're going to take the 6 and multiply it to both the 4 and the -3i. What's 6 times 4? 24. And 6 times -3i is -18i. Then we also need to take the -5i from the front and double distribute that into the back parentheses. So -5i times 4, -20i, and then -5i times -3i. Very good, positive 15i squared. Do we have questions about the double distributing part? Okay, then it just comes down to simplifying. So right now, there's nothing to combine with the 24 out in front, so we're going to leave it alone. -18i minus 20i. Those can combine. What does it give me? -38i. What can happen with that I squared on the end? We change it to a -1. When we multiply 15 by -1, what do we get? So it was adding 15, so now it becomes -15. If you want to put plus a -15, you can. It's just simpler to put -15. Do we have questions so far? We've got one more step. Can anybody see what the last step's going to be? Good. Combine the 24 with the -15. What does that give me? 9. So we can combine 24 with -15. That gives me 9 minus 38i. So the multiplication part takes a little bit more work if they are complex numbers, if they have a real part and an imaginary part. All right, on 13, we start off by double distributing. So I'm going to take 4 times 4 and 4 times 3i. What's 4 times 4? 16. 4 times 3i is a positive 12i. But then I also have to take -9i times 4 and -9i times 3i. -9i times 4 gives me -36i. -9i times positive 3i. Very good. -27i squared. All right. Our next step is to start simplifying these. Right now, there's nothing to combine with the 16, so we'll leave it alone. Positive 12i minus 36i. Good. -24i. Minus 27 times, we can replace I squared with -1. So on this one, we've got negative 27 times negative 1. What does it become? A positive 27. So on our last step, when we combine like terms, we have 16 plus 27, which gives us...
33.
What? Not 33. 43. 43 minus that 24i. That's our final answer. All right, finding complex solutions. So remember, we had a couple problems, not a whole lot of them, but a couple problems last week where the answer was no real solution, right? Because we were taking the square root of a negative and we hadn't learned how to deal with that yet. Now we know how to deal with complex or imaginary numbers, so we can solve these problems now. Yay for us. All right, on 14, how am I going to get x by itself? Subtract 100. So that leaves me with 4x squared equals negative 100. Then I would divide by 4. So I'll bring that up here. So x squared equals negative 25. To get x all alone, I need to square root both sides. So before I would have said, oh, no real solution, can't square root a negative. But now I would say that x equals 5i. 5i. So remember, all we had to do was simplify the square root of negative 25 like we were doing on Friday.
Where did we get the I from?
The fact that we had a negative under our radical.
We did this last week.
Getting x by itself on 15. What's my first step? Add 150. Negative 5x squared equals 150. Then I would divide by negative 5. So we are left with x squared equals
30.
negative 30. My next step is to square root both sides. Will negative 30 simplify?
No.
No. Even if we use a factor tree. If we try to factor 30, what do we get?
We get 30.
15 and 2. 15 breaks into 3 and 5. Do we have any pairs here?
No.
No. So here, the only thing that's going to simplify is the fact that instead of having a negative under the square root, how would I write this?
X square root of 30i.
X equals the square root of 30 times I. Again, you can have the plus minus in front.
Don't you have to put the I parentheses because it can't go underneath the...
So if you write it separated enough that I can tell it's separated, that's fine. But yes, if you want to put it in the parentheses to make sure I know you know the I is not underneath the radical, then go ahead and do that. Any questions before I make some room to do number 16? Okay, I'm going to take away example 14 so that we can do 16. So let's rewrite 16 up here. 8x squared minus 2, plus 2 equals 0. In order to get x by itself, the first thing I do is subtract 2. So 8x squared equals negative 2, and then I would divide by 8. That leaves me with x squared equals Can we simplify 2/8? Negative 1/4. Then what do I need to do? square root. If you want to just give the negative to the 1 in the numerator, you can go ahead and do that. That makes it a little bit easier to simplify, because we would have the square root of -1 over the square root of 4. We can split a radical over a numerator and a denominator. So what is the square root of -1 equal to?
Oh,
I. Okay, so we would have x equals I over, what's the square root of 4? 2. And again, we could have a plus or minus out in front of it. If you don't get the plus or minus on your paper today, I'm not going to make a big deal about it, but it is coming back.